Hello friends, welcome. We are dealing with the experiments related to operational amplifier and linear ICs. We are discussing about the comparator circuits. In the previous session, we discussed the voltage comparator using the IC741. In today's session, we will be discussing about one more comparator and its name is zero crossing detector. As the name indicates, it is detecting the zero crossing of the input, and depending on that the output is shifted between plus VCC to minus VEE and minus VEE to plus VCC as per the value of Vin. Now let us check what was the circuit diagram for voltage comparator. So this circuit we discussed previously. Here what I'll do, I'll disconnect the resistance and DC source of inverting terminal as well as non-inverting terminal, and I'll connect an input voltage, that is sinusoidal signal, to the inverting terminal, and the 3 is directly grounded. With that change I arrived with this circuit. See here, the Vin is applied at inverting terminal, so I call it as inverting mode zero crossing detector. Inverting mode, I hope you know that inverting, when I call a signal as inverting, when the output is out of phase by 180 degree with respect to input, that signal I'll call as a inverting mode. Now the operation remains like this. When I'll apply some sinusoidal input to the inverting mode and say I have applied this kind of sine wave. As it is an inverting mode, whenever the input is above the ground level, that time output is minus VEE, and whenever the input crosses 0, it is shifting from this end to the other end. As the input is below ground level, the output voltage remains constant at plus VCC until next 0 arrives. Hence the name zero crossing detector. For every crossing of the input from the 0, that is the ground level, the output shifts from minus VE to plus VCC to minus VE, and so on. Now we will connect this circuit on the breadboard and we will verify for the output. This is the circuit for ZCD connected on the breadboard. You can see I have not used any external resistances for this. Pin number 2 is connected to, you can see here, pin number 2 is connected to the signal generator, that is nothing but an input, and other terminal is grounded. Pin number 3 is grounded directly, this blue wire. Pin number 7 and pin number 4 are connected to plus VCC and minus VE respectively, and common terminal is connected to ground of the breadboard. Now at pin number 6 we are connecting the channel 2 of the DSO, and at input, that is pin number 2, we are connecting channel 1 of the DSO, so that we will get both the waveforms on the DSO. Let us turn on the dual power supply, the signal generator and the DSO. I have kept the frequency around 1.6 kilohertz. Okay, and voltage of it is around 2.6 peak to peak. So I arrived with this type of output. The yellow waveform indicates the input, that is a sine wave, and the blue one is output, which is shifting between minus VE to plus VCC. So why I called it as a inverting? You can see whenever input is in a positive half, output is minus VEE, and when the input is minus half, output is plus VCC. Now you can say that on paper I have drawn a straight line, but here it is slightly narrow. So this is because of the slew rate. Okay, if the slew rate is less, I will be getting more and more perfect waveforms. So this is another example for comparing the voltages using the op amp. Thank you.